The reason why algebra seems so complicated is because it takes us into all of the different number systems. Most people don't realize that we actually have 6 different number systems, and we're introduced to them in the order that we learn numbers. So the very first number system that we learn is called the natural numbers. And if you think back to kids, the first number that they usually know is the number 1. So the natural number system starts with 1, 2, 3, and it's just those numbers going up. As soon as they learn the concept of nothing, of 0, we enter the next number system. So the difference between the natural numbers and the whole numbers, simply the number 0. Now the whole numbers include all those natural numbers, but then zeros added to it. And we stick with that number system for a really long time until we pretty much get to pre-algebra. And at pre-algebra, we add in those integers, which are the opposites of our whole numbers. So if we have our 0 here and our positives on this side, our integers are those mirror images that come across and are equal distance away from 0, and they always face each other. So +1 and -1 are looking straight at each other. Now the rational numbers, we start to go into our fractions and decimals, but rational numbers are only our decimals that end, or sometimes we say terminate, or that repeat. Not every decimal ends or repeats. And when we get to those decimals that do not end or repeat, we are then into the next number system, which are the irrational numbers. Famous irrational number, pi. It never ends and it never repeats in a pattern. But also we have a lot of our square roots. Those are also irrational numbers. Now the real numbers are every single number system before it. They include every number that exists. So the moment we're in the real numbers, we're working with every number. Now the real numbers, we can compare them, we can order them. Everything we've done with the other numbers we'll do in this system. The key, it's the decimals. Whenever we're looking at any numbers in the real number system, we always want to look at them in decimal form, because that's going to tell us, are they rational numbers or are they irrational numbers? So if we take a look at rational numbers, remember they end or they repeat. 3/4, when I take it to decimal form, is 75/100. It ends. Therefore, it has to be a rational number. But remember, not all of our square roots are irrational numbers. If I have perfect squares, and if I take the square root of 81, I get 9, and I take the opposite, well, again, that ends, because technically after 9, I have a decimal. And if I have what looks like a complicated fraction, I have the square root of 16 divided by 5, well, remember, I can take that square root on the top, which is 4, divided by 5, and if I take it to decimal form, that's 8/10. It ends. So those are all rational numbers. Even though at first glance we weren't thinking they were rational numbers, you have to check them in decimal form. Now the same applies for irrational numbers. If I take the square root of 8 and I put it in the calculator, I get a decimal number that keeps going on, and notice there's no repeating patterns. It never ends. Therefore, it has to be an irrational number. And if you have a decimal inside of a radical sign, that also is never going to end or repeat. That's going to be an irrational number. So that's how we see the difference. Now, when we go to compare numbers in the real number system, again, we can't use our less than or greater than or equal sign unless we see what they are in decimal form. Just by glancing here, I have no idea which is bigger and which is smaller. So when I go to decimal form, I get a long decimal. I don't need to write out the whole decimal, because I just need to compare it to this whole number here. Well, clearly 3 31/100 and so on is larger than 3. That's how I can compare it. So again, I'm relying on that decimal system. And when we're ordering real numbers, they look very complicated. No one would be able to tell the difference of what's the smallest and what's the greatest unless we take it to decimal form. So if there's one thing to remember about today's lesson, you always have to take all real numbers in the real number system to decimal form to really see how to compare or order them. So when we go to the decimal form, then it becomes really clear which is the smallest and which is the largest. And we can order ours from least to greatest. So it's not complicated. It just takes a little work to make the conversions, but once you do that, then it's really easy to work in the real number system. Great introduction to all the numbers in our world. We have really taken a step forward because now no numbers are off limits. Good luck and have fun.